of recording this proceeding. Okay, so the last part of the proposal, no, if I may start, is the identification of the statistical tool that you will be using to answer your research question. So nakita niyo yung sunod-sunod natin na lesson. Although hindi natin dinetalyado part by part yung proposal and hindi ganoon yung procedure natin ng pagdi-discuss, yung mga elements na kailangan ninyo doon sa proposal, yun yung binigyan natin ng highlights. So, yung theory that you are going to use, no, to guide your research, and then nakapag-identify tayo ng variables within theory. We were able to write your objectives in a form of research question based on the theory. And then the hypothesis that you forwarded ay base din doon sa research questions. And then you come up with the instruments that you are going to use. So yun yung ginawa nating huli na activity, that you are going to identify the possible theory instruments or measures for your variables, whether it is adapted, modified, or and you gather the data. Meron kang data collection procedure, how you're going to do that. And then the last part would be how are you going to process the data in terms of interpretation. So how are you going to analyze the data? What tools do you need, no, to analyze the data, make sense of them? How are you going to make the data sensible in a way that it will yield to an answer to your research question? So for example, you wanted to find out whether boys have lesser anxiety than girls in a math test. So ang instrumentation mo doon is you give a measure of anxiety for both girls and boys. And then after some time, you give them a quiz or a test. So na-measure mo yung anxiety, na-measure mo yung test, and then the research question that you forward is there gender difference, no, in terms of anxiety and in terms of performance? So what tool you are going to utilize to answer that research question? So you have to rely on the numeric measures that you have. So meron kang mga ipaprocess na mga individual scores of the students, and then you're going to compare the levels of anxiety and levels of performance of this group of students. So yun yung ating pag-aaralan ngayong hapon, but we will not discuss the detail on how to do it, no, because there is a statistics class for that, particularly the use of software. So ang lesson natin ngayon is i-identify lang natin as much as possible ano yung statistical tool na gagamitin mo kung ito yung problem. Okay, kasi sa proposal hanggang doon lang naman. So hindi naman tayo hahanapan doon sa proposal ng ano yung steps, or pakita mo nga kung paano mo gawin itong ANOVA, for example. Hindi naman, kundi alam mo lang na ang gagamitin ko dyan is ANOVA, or ang gagamitin ko dyan ay regression analysis, because that's the most appropriate statistical tool for your research question. So marami tayong research questions, marami tayong statistical tool. There is a match between the two. So hindi pwedeng, gusto ko ng multiple regression kasi alam na alam kong gawin yan. So it's not enough that you know it, kundi dapat ay appropriate ba o pinaka appropriate ba na statistical tool yung multiple regression kaya mo siya gagamitin. So needless to say, statistical tool is just a tool. It's just a method of analyzing your data. It never is the consideration for identifying a research problem. Matagal lang na-identify yung research problem, matagal lang na-identify kung ano yung hypothesis, meron ka ng instrument na gagamitin bago ka palang makarating dun sa anong statistics ang gagamitin dito. It never starts with statistical tool. Ang dulo niya ay what statistical tool will I use to analyze the data. Okay? So allow me to share my screen. Ivan, enable mo nga yung aking screen sharing.
Wait lang po.
Ivan, yung naka-disable yung screen sharing mode noong Zoom meeting natin. Sir Ivan?
Wait lang po. Sir, pa-check nga po kung okay na po.
Okay. Do you see my screen now?
Yes po, sir.
Yes, sir.
Okay, so I have here 28 slides, pero mga examples lang karamihan ito, kaya medyo mahaba. Pag meron kayong tanong, tanong kaagad para hindi masyadong malayo yung pagitan ng items before your question. So I have here a presentation of the different statistical tools that we use in quantitative research. And I would like to begin the presentation with identifying the major research questions, the number and the kind of variable that you will be using, and what is the appropriate analytic strategy that you are going to use. Okay. So generally, sa quantitative research, merong 4 na research questions or major research questions. But for this class, we are going to talk about the first 2. Kasi yun naman ang concern natin sa subject natin, and in particular in the master's level, ay dito lang umiikot yung ating statistical tools because these are the major research questions that we are trying to address. Okay, ulitin ko, there are 4 major research questions in quantitative research, and we are going to deal only with the first 2. The first one is, ang major research question mo ba deals with the degree of relationship among variables. So are variables related? So yun yung unang research question. So meron tayong 3 column dito na kung saan naka-identify ano ba yung independent variable mo, ano yung dependent variable, at ano yung analytic strategy na kailangan mo dito. So nakalagay din dito sa loob kung ilan. So ibig sabihin ng number is either isa or multiple. So pag sinabing multiple, 2 or higit. Then meron tayo dito mababasang continuous at saka discrete variable. Okay? So pag sinabi nating discrete ang variable, ito yung mga categorical. Ito yung mga grouping variable. For example, gender. Gender is a discrete variable kasi categories siya. Male, female. Another variable ang discrete is educational attainment. Discrete kasi eksakto, you only belong to one group. Elementary, high school, college. So lahat ng variables that take place, integral values and groupings are called discrete variables. Okay? Pag sinabi natin continuous, ito ay yung mga variables that could take any value between 2 given numbers. For example, 6.5. Pwedeng 7.0, pwedeng 6, pwedeng 6.1, pwedeng 6.3. They are continuous variables. So yung mga measured from a scale, those are continuous variables. So halimbawa, grades. Yan, continuous yan. Age is continuous. Kasi age can be expressed not only as integral or whole numbers like 16 or 17 years old. They can also be expressed as 16.3, 16.5, etc., etc. So kailangan ma-identify lang natin kung anong variable yon. Dalawa lang naman ang kategorya ng variable natin, either ito ay continuous or discrete. Ngayon, na-discuss na natin last time, ano ang ibig sabihin ng independent at anong ibig sabihin ng dependent. So, independent is the assumed cause. Dependent is the assumed effect. Okay? Klaro tayo doon. So, sabi dito, if I have one independent continuous variable and one dependent continuous dependent variable, then the analytic strategy is bivariate R. And there are three types of bivariate R. Mamaya, i-discuss natin na isa-isa. For example, I want to correlate math and science grades. Parehas na continuous yun. So, it's bivariate R or correlation. So, the small r there is referring to correlation. So, kung meron akong independent variable na continuous, pero ang dependent variable ko ay discrete, hindi pwede ang bivariate R. It's a different test. Bakit? Dapat parehas daw silang continuous. For example, length of time of review correlated with math performance. So parehong continuous yun. If I have multiple, marami ang aking independent variable na continuous, at isa lang yung continuous na DV or dependent variable, then it's called multiple regression. So the small r there is correlation, and then the multiple r, the big R there is regression. Then meron nakalagay sa ilalim, it can be discrete but dichotomized. So for multiple regression, pwede ang mga discrete or grouping variables, but they have to be dichotomized. Example, pwede doon ang gender or sex, biological sex, male and female. Pwede doon ang type of school, public and private. Pero pag naging tatlo na yung levels of your independent variable, halimbawa ay low, average, high, hindi na pwede. Ilocano, Tagalog, Kapampangan, hindi na pwede. Dialect spoken, for example. So as long as the independent variable is dichotomized, pwede siya maging discrete sa multiple regression together with the continuous one. Pero ang ideal, ulitin ko, ang ideal for regression and correlation, dapat both the independent and the dependent variable are continuous variables. So later we'll try to explain through added examples. If I have multiple continuous IV na lang itatawag natin na para mas madali. If I have multiple continuous IV correlated with multiple continuous DV, then canonical correlation ang gagamitin natin. So basically, that's the first group of statistical tool, no? The one that answers degree of relationship among variables. The second major research question is determining significance of group differences. Ito yung mga comparison. Okay? Ito yung mga tests na nagko-compare ng dalawa or higit sa dalawang grupo. Depende kung saan mo sila kinukumpara. Okay? So nakita nyo yun? Ganun pa rin ang presentation. I have IV, DV, then ilan, at kung anong kind ng variable. So for example, meron daw akong isang discrete IV at meron akong isang continuous na DV, then it's either one-way ANOVA or t-test. Example ng one discrete, gender. discrete ang gender kasi it can be grouped as male or female. The dependent variable na continuous ay IQ, for example. So the research question is, meron bang gender difference sa IQ? So I could use one-way ANOVA or t-test. So mamaya, i-explain natin ano yung pagkakaiba ng mga t-test na yan, ano-ano iba't ibang uri ng t-test, at ano ang pagkakaiba nito sa ANOVA. So dito sa one-way ANOVA, kahit na ilang groupings yung discrete mo, basta discrete. For example, pwede ko bang ikumpara ang IQ according to dialect spoken? Pwede. Because dialect spoken is discrete. Pwedeng 3 or 4 na groups yan. Ilocano, Tagalog, Kapampangan, Cebuano. Halimbawa, meron kang 4 na dialect o groups of dialect spoken. Then pwede mong gamitan ng group difference comparison using one-way ANOVA. Okay? Kung marami ka naman na independent variable, you have 2 discrete like gender and dialect. Okay, gender and dialect. Kanina gender lang, one-way ANOVA. Ngayon, dalawa yung independent variable, mayroong interaction effect, gender and type of school affecting IQ, then it's called a factorial ANOVA. Okay, so one-way ANOVA is 1 ang IB, then factorial magiging 2 yung IB, pero isa lang yung DB. Okay. Pagka naman isa lang yung IB na discrete at marami na yung DB, for example, gender differences in terms of emotional intelligences. Tapos merong subscales, A, B, C, D. So merong 4 na subscales, multiple continuous. So instead na one-way ANOVA, for each of the scale, ang gagawin natin ay one-way MANOVA or Hotling's T-square. So parehas lang yan. Yung one-way ANOVA, isang IV, isang DV. Dito sa multiple na continuous, one-way MANOVA. The M there is multivariate analysis of variance. So ANOVA is analysis of variance. So dahil multiple, yung dependent variable, it becomes a multivariate analysis of variance. And then pag in-extend mo yon, ginawa mo ring multiple yung ID mo at multiple yung DB mo, so it goes factorial MANOVA naman. So instead of factorial ANOVA, it becomes factorial MANOVA. Okay, do you have any question for that part muna before I proceed with the specific examples? ANOVA, factorial ANOVA. MANOVA, factorial MANOVA. Meron ba kayong ganyan na research question sa inyo? Meron na bang nahahawig? O nakikita nyo na ba yung direction ng inyong magiging research question? Una, degree of relationship among variables. Pinagko-coordinate mo yung variables, either isa or pares. Then yung pangalawa naman ay, is your research question talks about differences. So yung mga quasi-experimental, madalas dito yon sa significance of group differences. Through experimental or quasi-experimental kasi nagko-compare kayo ng control at saka ng treatment group. So most likely dito kayo papatak sa major research question number 2 and that talks about significance of group differences. Halimbawa, meron ka 2 grupo, tinuruan mo ng method X and method Y. Alin ang mas effective? Method X or method Y? So, yun ang ANOVA or t-test kasi comparing one discrete ID. Ang variable mo doon ay the groupings. Ano-ano yung level? Group 1, method X. Group 2, method Y. So, dalawang levels. Iba yung levels sa kind of sa number of variables. Isa lang yung variable mo doon, that's the grouping. 2 level siya, method X and method Y. Parang gender. Gender is the variable, then 2 ang level, male, female. Then saan mo sila ikukumpara? Yung test. Kung ano yung test na ibibigay mo, yun yung DV mo na continuous. So mayroon bang difference? So you use a t-test or one-way. Okay? So far, wala pang tanong? Yung pangatlong major research question talks about prediction of membership. Babalik rin mo itong significance of group differences, magkakabaliktad siya. Yung DV magiging ID. So we will not talk about that here because it's multivariate stat. So sa stat 2 naman yon. At yung pangapat na major research question talks about structure. Structure of the model that you are going to propose. So beyond then, sa scope natin yon. So that's stat 2 also. So ang ating concern ay dito lang naglalaro sa unang dalawang major research question. Either you talk about relationship of variables or you talk about establishing significance of group differences. Okay? So bahagi din ng qualitative analysis yung descriptive statistics. Yung pinakita ko kasi na unang dalawa, yun yung mga inferential statistics. Yun yung ginagamit natin sa hypothesis testing. But part of your research question usually begins with descriptive statistics. You want to describe the variables as they exist. So may mga variables tayo na kailangan mo natin i-describe bago natin gawan ng inferential statistics. So ano-ano yung mga descriptive statistics that we use? Una, frequency counts and percentages. No, laging magka-partner yan. When you count something, use frequency counts, automatically ang ka-partner nun kagad ay percentages. Sometimes we are interested also to present frequency counts and percentages, but we highlight the ranks of responses. So may ranking. Okay, so ano yung first, ano yung second. But of course, the rankings are based also on frequency counts. Okay, sometimes magkasama sila, sometimes ranks na lang. Okay, and of course, hindi mawawala sa descriptive statistics as the most reliable ones are the measures of central tendency, which is the mean, and a measure of variability, which is the standard deviation. So we summarize scores, that's the mean. We summarize the deviations from the mean, that's called standard deviation. So ito yung dalawang importanteng statistics na descriptive kasi dito sa second major research question, dito sa significance of group differences, ang input lagi natin dito ay yung mean at standard deviation. So ang kinukumpara natin dito ay not individual students, but group of students compared to another group of students. Therefore, means are compared. So mean comparison ito. Kaya, it's important for us to know the idea of what is mean and what is SD. So ang ganda naman doon sa SPSS or sa ibang software, hindi na natin kailangan i-compute ng mano-mano yung ating values for mean and SD or frequency counts and percentages even for a large data set because it has the capability to do that large-scale calculations. So wala na tayong issue doon. Hindi na natin problema na ay ang hirap-hirap mag-compute. So it's the software who does or which does the computation. Ikaw na lang mag-i-interpret kasi hindi naman niya kayang gawin yan. Okay? Example, ito. Frequency counts and percentages. Ang tawag natin dito ay frequency table or frequency distribution table. For example, your variable is sex, then the category is male or female. So usually, frequency refers to the number of observations for each category. So out of 58, you have 26 males and 32 females. So automatic yun na pag nag-frequency counts ka, automatic ang kapartner niya kaagad ay percentages in tabular form. Pwede rin yan pie chart kung gusto mo. Pwede rin bar graph. But those are just graphical representations of this table. Okay? So yan yung frequency counts and percentages. Now, Kung gusto mo naman ng ranking, you also have frequency counts, you have percentages, you have the rank there, and then you have the items in the first column. For example, on this table, reasons for dropping from school. So I want to present as a researcher what are the reasons of students for dropping the school. But aside from that reasons, I want to highlight what is the most prominent reason. Then ano-ano yung susunod. So ganun din, I will count students' responses. So 56 out of 160 is 35%. And since 56 is the highest number, that ranks first from the list. So hindi lahat ginagamitan ng rank. Katulad nito, itong gender, hindi mo na ito gagamitan ng rank. Kasi dalawa lang naman sila. Of course, pag mas mataas yung isa, di mas mababa yung isa. So we usually don't use percentage, we don't use ranking for grouping variables like gender, type of school, dialect spoken. Enough na yung frequency counts and percentages. Madalas ginagamit natin ang ranking kung the rationale for doing the rank is necessary. Example, you ask the students to score, no, from their most to the least favorite subject in class. So you have different subjects here, and then you ask the students, then yun, irarank mo yung kanilang mga response. So lalabas doon, ang pinakagusto nila is English, for example. Then susunod din science, then Filipino, then panghuli yung math. So ang highlight noon is ranking talaga. That's why you use ranks as frequency counts. Actually, kahit na hindi natin lagyan ng ranking ito, makikita pa rin naman, di ba? Makikita pa rin naman na 56 is the highest. Kaya lang, with emphasis nga doon sa ranking, kaya you add another column for that. But the meaning does not change. 56 is the highest frequency corresponding to financial problem, that's 35%, kahit na hindi ko lagyan ng ranking. But again, ulitin ko, since the emphasis is to establish the fact that these are ranked responses, maglalagay ako ng pangatlong column. Okay? Then, ito naman example ng mean and standard deviation presentation of variables. For example, I want to present students' academic performance in terms of the final grades across math, English, science, Filipino, mapaya na rin yung palipunan. So, I have 1,000 students, for example. Then these 1,000 students' grades are summarized using mean and standard deviation. So this 87.34 is no longer the grade of the highest student, not the grade of the lowest student, but this is the combined grades of all students from my list. So ang formula lang naman ng mean is the sum of all the grades divided by the number of the grades. So if I have 1,000 students, I add the grades of the 1,000 students divided by 1,000. So that takes a lot, di ba? So again, hindi na yung problema kasi meron tayong software. What about standard deviation? Ano ibig sabihin ng standard deviation na 6.5? Ang ibig sabihin niyan, on the average, the distance of all the grades from the mean, which is 87.34, is 6.5. That standard deviation tells us whether the grades are close together or relatively far apart. So the higher the standard deviation, the scores are scattered from the mean. The smaller the standard deviation, the closer the scores are from the mean and within each other. So pag titignan natin dito, ano ang pinakamataas na grade nila? It's 90.78. Ang mean kasi, the higher the mean, the higher the scores. Kasi saan ang galing yung mga mean? Sa scores na inad mo. So the higher the scores, the higher the grades. Pero the higher the standard deviation, ang ibig sabihin nun, the more the scores scatter. Mas heterogeneous yung grupo kasi kalat-kalat yung score nila. So, tignan natin. Pinakamababa sila sa Pilipino, 84.32. Pero pinakamababa din ng standard deviation. Ibig sabihin nun, their scores do not scatter from very high or very low. So medyo homogeneous sila pagdating sa Filipino. Samantalang sa Araling Palipunan, ang taas nga ng kanilang mean, 90.78, that's on the average, pero ang taas din ng standard deviation. On the average, the distances of the scores from the mean is 8.34. So if I may interpret that, ang grades daw nila sa Araling Palipunan ay naglalaro between 90 plus and minus 8. Ibig sabihin nun. So ano yung 90 minus 8? It's 82. So 82, then 90 plus 8 is 98. So 82 to 98 yung range ng karamihan sa mga estudyante. Sa Filipino, it's just 82 to 86 to that range. Sa math naman ay 81 to 93. So yun ibig sabihin ng standard deviation. Plus minus lang yun sa mean. To give you an idea kung ano yung grades ng estudyante. So kung meron ako dito, halimbawa ay, if I may add, nakita niyo ba to? If I may add TLE, and I say 85 and it's 0, what does it mean? Sir Jomar. Sir Jomar, pakisagot nga yung tanong ko. Halimbawa, ang grade nila sa TLE ay 85 at ang standard deviation ay 0, what does it mean?
Parang 85 po sila lahat.
So walang deviation, di ba, from the mean. 85 ang grade ng isa at 85 din ang grade ng 999 pang iba. And of course, that is impossible. Di ba? Kahit na nga tatlo lang yung estudyante mo, mahirap na magkapare-pareha sila. So much more if you have 1,000 students. So sabihin natin meron. Yan, maliit lang. 1.5. So in other words, there is less variability on the grades. 85 is the average and the variability is roughly 1.5. So naglalaro lang sa 83 to 87 yung grades ng estudyante nung 1,000 students. Sir, meron nakitang 80. Oh, those are outliers. May nakita akong 89. Those are outliers. Konti lang yon. Karamihan sa kanila, naglalaro lang dun sa grades na yan. Okay? Yun ang ibig sabihin ng mean and standard deviation. Now, let's go to the specific inferential statistics or testing hypothesis. And we talk about comparing means as the first group. So, pagdating sa comparing means, or means are the averages, the first one is called the one sample t-test. So, when do we use this? The one sample t-test procedures test whether the mean of a single variable differs from a specified constant. So meron kang reference na constant at gusto mong ikumpara yung scores ng isang grupo doon sa constant na yan. Example, a researcher or a teacher at that might want to test whether the average achievement score for a group of students differs from 80. So 80 is the specified constant. Gusto mong malaman kung hindi daw ba nalalayo yung grades ng estudyante mo, whether you have 50 or 70 students, doon sa reference grade na 80. Halimbawa, ang compute mo ay 79.3. So the question is 79.3 equal or not equal to 80? So one sample t-test will give you the answer. So hindi sila magkamukha, di ba? 79.3. O baka naman yung 79.3 at 80 ay parehas na or not significant na yung difference niya. So hindi mo pwedeng sabihin, magkaiba, so there's a difference. Kailangan mo i-test using the one sample t-test. Or another example is whether the mean weight of the sample respondents differ at 100 pounds. At ang confidence level mo ay 95%. So ang alpha mo ay 0.05. Yung error mo ay 5% lang, 95%. So later sa testing of hypothesis sa statistics, aaralin natin yon. Anong pagkakaiba ng 95, ng 99, at ng 99.9. Pero in a nutshell, ang one sample t-test is just comparing a mean to a specified constant. So that specified constant is predetermined already. Even before you gather the data, meron ka ng specified constant. Okay? Saan madalas ginagamit ang one sample t-test? Example, sa isang kumpanya na nagpo-produce ng small items, for example, yung mga pansit canton. Balawan na pansit canton. So yung pansit canton, estimated weight nakalagay, di ba? Sa pakete, estimated weight ay for, halimbawa, 100 grams. Not sure, ano, halimbawa, 100 grams. So, hindi naman eksaktong 100 grams lahat yon bawat pack. For example, in a box of 50, hindi lahat yon ay nagme-measure ng exactly 100. Pero nakalagay ay 100. So, ang gagawin mo para matest is you weigh each of the packs. Some will weigh less, some will weigh more. And then you compute the average of these packs and compare that to 100 and tell whether significant ba yung diferensya o hindi naman using one sample t-test. Okay? The second one is paired sample t-test or known as dependent samples t-test. This time naman, you are comparing two means, pero from a single group only. So the paired sample t-test procedure compares the means of two variables for a single group. The procedure computes the difference between the values of the two variables for each lobat and tests whether the average differs from 0. Dili lang ha, magsasaksak lang. Okay? So example, in a study of high blood pressure, all patients are measured at the beginning of the study. They were given a treatment and measured again. Thus, each subject has two measures, before and after measures. So ito yung pre-test, post-test. Susukatin mo muna sila. Susukatin mo isa-isa. If I have 50 samples, then i-record ko in a column yung observations or measures ng 50. Then after the intervention or treatment, susukatin ko ulit. Second column, magka-partner yun, di ba? Papares mo. So, i-compute na ngayon yung mean 1, then i-compute niya yung mean 2, then i-compare niya yung mean 1 versus mean 2, and test whether the average differs from 0. So, ang kaibahan nito sa one sample, meron ka ng specified constant. Dito naman, wala pa, pero dalawa yung means. Pero galing lang sa isang grupo. Another example, how would you know if there was a significant increase in the post-test of the students after they were exposed to a treatment? Example, a new method of teaching. So meron halimbawang gustong implement na method of teaching, para malaman mo kung magiging effective yon, pag pre-test ka, bago mo isagawa, then mag-post-test ka, then saka mong ikumpara using paired sample t-test. Example, ang pre-test nila 70, ang post-test nila ay 90. Significant ba yun, Miss Kabilin? 70 ang pre-test tapos naging 90 after 2 weeks on the same skill or the same task. Joyce, do you think that's a significant increase from 70 on the average, then naging 90? Ms. Ramos, do you think that's significant? 70 tapos naging 90? Nakakonect pa ba ako? Can you still hear me?
Yes, sir.
Sa Riniel na lang. On the average, 70 nung una, then nagturo ako ng yung method, tapos after 2 weeks, nag-post test ako naging 90. Do you think merong significant difference yun?
Feeling ko po, sir, meron po.
Okay, so in other words, parang obvious reasons, di ba? Parang obvious naman, sir, na ang laki nung pinagbago, di ba? From 70, naging 90 points. Or 70%, naging 90%. So, in that example, siguro, pwede kong sabihin, sir, kahit na hindi na natin i-test, di ba? Kahit hindi na natin i-statistical analysis, parang common sense dictates that there is an increase. Okay? Pero kung halimbawa 70.90 tapos naging 73.75, o yun yung mga instances na kailangan mong i-test kasi teka, baka naman by chance lang yun o baka naman negligible yan o baka naman talagang mayroong pagkakaiba. Kasi kasama doon sa equation yung standard deviation. Hindi lang yung mean.
Yes.
So sa t-test, sa formula niya, although hindi natin aralin na mano-mano, nakasama sa equation ang values ng standard deviation. Kaya yung variance or differences ng scores ay importante sa mean comparison. Okay? But theoretically, dapat naintindihan nyo lang ang ibig sabihin ng paired sample. Ano? Dalawang scores galing sa isang grupo lamang ang kinukumpara. Yung one sample, isang mean, compared sa isang specified constant. Okay. Paano naman kung meron kang dalawang grupo? Ito naman yung independent samples or two samples test. So this procedure compares means for two groups of cases. So dalawang grupo, ideally, for this test, the subject should be randomly assigned to two groups so that any difference in response is due to treatment or lack of treatment and not to other factors. So madalas ito yung ginagamit natin sa experimental. So you have two groups randomly divided into two. So pag sinabing natin random, doon sa sampling natin, halimbawa meron akong 50 students, hahatiin ko ito sa dalawa in random. So I have the list of the students on a bowl and then I will pick the names in random. Sino ang 1, sino ang 2, 1, 2, 1, 2. Then pag na-divide ko na sila, randomly naman, pipiliin ko in random again, i-assign ko kung sino sa kanila ang treatment group at sino ang experimental group. Para daw, complete random yung assignment. And then, magbibigay ako ng pre-test sa kanila. Dapat sa pre-test, pantay lamang. Then after some time, susukatin ko ulit sila at malalaman natin doon kung may pagkakaiba yung post-test. So dapat sa pre-test, equal sila. Sa post-test, ang focus natin. Example. Patients with high blood pressure are randomly assigned to a placebo group and a treatment group. Pag sinabing placebo, inactive yun. Diba? Vitamins o kaya harina lang. Akala lang noong pasyente na pinapainom siya ng gamot pero hindi siya gamot kasi it's a placebo. And the treatment subject received a new drug that is expected to lower blood pressure. After the subjects are treated for 2 months, the two sample or independent sample t-test is used to compare the average blood pressures for the placebo group and the treatment group. Take note that each patient is measured once and belongs to one group only. Pero syempre, ang kanilang criteria dito, dapat you are suffering from hypertension. So, mayroong other variables, syempre, na i-control dyan. Dapat pare-parehas ang edad, dapat pare-parehas ang comorbidities, etc. etc. Everything should be equal. Kasi kung mayroong mga hindi constant among them, baka yun ang maging factor, hindi yung gamot. Siyempre ito, restricted diet to, di ba? Kasi experiment ito eh. So they are placed, for example, for a period of 2 months in the facility or in the laboratory facility of the pharmaceutical company. And then, naka-measure siyempre ang diet nito. Dahil diet should be made constant also, sleeping patterns, etc. etc. All are made constant except that one group is receiving a treatment and another group receives the placebo. So, After 2 months, susukatin daw ang BP. So ang ina-expect natin dito, mas lower yung average BP ng treatment group kaysa sa placebo group to declare that the new drug is effective. Controlling for all other variables that could affect blood pressure. Okay? So sa klase naman, paano to? Students were randomly assigned as group 1 and they were taught using the new method of teaching and they were called the treatment group. Group 2, on the other hand, will be taught using the traditional teaching method and they will be the control group. After some time, the students were given an achievement test. Is group 1 better than group 2 on the test? So, ang statistics natin dyan ay independent samples because there are 2 groups being compared. Randomly assigned. Okay? So pagka ang tanong ko ay, sir, nagbigay ako ng test sa math, gusto kong ikumpara yung lalaki at babae. Still pares, pwede pa rin ba ang independent sample t-test? Pwede, pero hindi na siya ang appropriate kasi gender is not randomly assigned. So ano ang gagamitin natin? Oh, we can use ANOVA. Pero parehas lang ang result. Kahit ANOVA ang gamitin natin or independent sample t-test, the results will still be the same kasi it's the same means pa rin ang kinukumpara niya. Kaya lang, in terms of appropriateness, we use independent sample t-test to compare 2 groups when, in fact, they are randomly assigned. So since gender is not randomly assigned, we use the ANOVA. Okay. Next. Yan. One-way ANOVA. The one-way ANOVA computes the analysis of variance for the independent single isa lang. Analysis of variances used to test the hypothesis that several means are equal. Several means 2 or more. In addition to determining what differences or the differences exist among the means, you may also want to know which means differ. So ulitin ko, if I want to compare 2 groups in terms of a DV, which is continuous, at hindi randomly assigned ang grouping, then the most appropriate tool will be ANOVA. Kung 3 yung grouping, mas appropriate yung ANOVA. Kung the one-way ANOVA, I have students who are who took the exam out whether the effect. Hindi ko naman ni-randomly assign ito, kundi sinurvey ko lang. Sabi ko sa kanila, okay, after your exam, gusto kong malaman kung anong type of review ang ginawa ninyo. Sino yung mga nag-self-review? Taas ang kamay. Sino yung mga nag-pair review? O pares-pares? Taas ng kamay. Sino yung mga nag-group review? Then, magtaas ng kamay. Very magkakaiba. One-way ANOVA because I have 3 groups and these groups are not randomly assigned. Malalaman ko din dyan kung sino ang pinakamagaling at sino ang pinakamababa. At malalaman natin kung yung bang 1 versus 2 ay magkaiba, yung bang 1 versus 3 at yung 2 versus 3. So I can compare pairs of means aside from all means being compared. Okay? Example 2, is there a significant difference on the teaching performance of the university teachers in terms of their educational qualifications, BS, MS, or PhD. So ang independent variable natin dito is discrete, educational attainment, BS, MS, or PhD. Ang dependent variable natin ay continuous, teaching performance. So ikukumpara ko silang 3. That's one-way ANOVA. Okay. 2 or more. 3, 4, 5. But if you have 6, 7, magulo na yung comparison. The ideal for ANOVA is hanggang 4 na grupo or groups. So make sure that your independent variable can be categorized into that much of variables. Kumbaga, wag nang sosobra doon kasi the comparison becomes too complex at baka hindi na masyadong mag-equal yung mga numbers ng groupings na ito. Very crucial kasi yung dami nito. Ano? Hindi pwedeng yung self-review ay 20, yung peer review ay 100, at yung review na group ay 4. Although may mga means ito, may standard deviation, eh sobrang lalayo naman noong numbers nila when they are grouped accordingly, hindi rin yun reliable. So, if you have so much groupings or so much categories, the tendency for them to vary much in terms of sample size is high. So, pero wag namang piliting dalawa lang. Halimbawa ay Catholic and non-Catholics. Masyado namang nilimit, no? Kasi yung non-Catholic, masyado pang varied yon. Okay? Masyado pang madami para ilimit mo lang sa isang grupo. Hindi naman sila magkakasama ng religion. Tawag nating false dichotomy. Dinichotomize mo para maging dalawa lang, pero actually, it doesn't make sense. Okay? May tanong ba tayo dito sa one-way ANOVA? Have you tried using this one? No, for the math majors, have you tried? O yung mga ano, matanong ko nga yung mga nag-thesis, Miss Maylin Ariola. Doon sa thesis mo dati, nung ikaw ay nag-psych, ano yung statistics na natatandaan mong ginamit mo?
Parang ito pong one-way ANOVA.
Hello?
Sir, open na po yung mic. Sir, yung sa
Yes.
one-way, ito po sir yung ginamit ko po. One-way ANOVA.
Do you mind to share kung ano yung naging research question mo? Bakit ka nagamit ng one-way ANOVA?
Parang is there a significant difference? Stress of their ranking po sir yung ginamit. Hindi ko po ma-recall eh, pero one way po yung...
So ilang grupo yung kinumpera mo, ma'am?
Sir, yung ano nila sa ano eh, yung work, yung sa may assignment nila, yung rank nila sir, halimbawa po eh, police officer 1, 2, ganun po. Police officer 3, parang ganun po sir. Ang pagkakaalala ko po.
Tapos, tinignan mo kung may
Opo,
pagkakaiba yung
stress,
kanilang
opo.
stress level. Pero if I may reanalyze that, parang hindi ANOVA yon kasi ordinal yung IV, so dapat yun ay Spearman correct.
Din sir, may one way.
Pero tama naman, may groups naman sila according to their ranks.
Opo.
Parang ito, BS, MS,
Yes.
PhD.
Opo.
Ganon. At the same time kasi ito parang arranged in according to higher, di ba? Papataas yan. Pero kung ranks na siya mismo, halimbawa, I want to know the performance of teachers in terms of academic rank from instructor to professor 6. So, ordinal na yon in order, ano na siya, Spearman correlation na ang gagamitin dito doon.
Okay po.
Na mas appropriate. Okay? Kasi masyado ng maraming grouping kung instructor 1, instructor 2, instructor 3, assistant 1, 2, 3, 4. Ang dami na mismo. Eh nakarank naman sila ng sunod-sunod. So ordinal na siya. Si Gian nga, Miss Perez, do you still remember kung ano yung statistical tool na ginamit mo nung nag-thesis ka?
Sir, qualitative po yung thesis namin.
Qualitative. Okay. So sino yung mga quantitative na gusto mong i-share para lang malaman natin kung meron na tayong item na nababanggit dito. Si Miss Dupitas. Miss Jemmarie, do you remember your statistics?
Hello po. Sa amin sir, multiple regression po.
Multiple regression.
Opo.
So meron kang mga predictors, tapos meron kang variable na predict. Ganun.
Yes po sir.
Ayan. So nabanggit niya, yun na yan. Papunta na tayo doon. So summarize natin yung ating iba pang variations ng mean comparison. So pag isa lang ang IV, categorical. So ang idea sa mean comparison, lahat dapat ng IB mo categorical lang, grouping, discrete siya. Tapos yung IB mo, continuous dapat. Lahat ng DB dapat continuous. Pagka ang DB mo ay discrete, baliktad yon. Discriminant analysis, hindi yun mean comparison. Okay? Isang IB, isang DB, t-test or ANOVA. Dalawang IB, pero hindi interaction effect. Isa lang din ng DV, main effects ANOVA. So mag-ANOVA siya sa unang IB, mag-ANOVA rin siya sa dalawang IB, sabay nga lang. Pag marami kang IB, tapos kukunin mo ang interaction effect, nabanggit na natin kanina, it's called factorial ANOVA. Tapos meron kang covariate, ang tawag doon ay ANCOVA. Analysis of covariance. Nag-ANOVA ka, pero meron kang variable na gustong i-control. Kasi nag-i-exist siya as a variable, hindi mo naman kayang tanggalin, control mo na lang. Pag marami kang dependent variable, yung ANOVA magiging MANOVA. Tapos meron kang control variable, it's called MANCOVA. ANOVA, ANCOVA. MANOVA, MANCOVA. Okay? Then meron din tayong, pag i-extend natin yan, meron din tayong factorial MANCOVA. Factorial MANOVA. Pwede rin. Depende kung ano yung research questions na pino-forward. So lahat nito aaralin natin to sa stat. Huwag kayo mag-alala. At this point in time, hindi nyo alam paano to gamitin. It doesn't matter yet kasi hindi naman ito yung ating klase pa. Pero dapat alam mo na gusto kong malaman yung interaction effect ng gender at type of school sa IQ. Gender and type of school sa IQ. So that is a factorial ANOVA. Pero I want to control EQ. O, this is factorial ANCOVA. Hanggang doon lang. Ngayon, kung paano gagawin yon, o di i-equip natin yon pag nag-aral tayo ng statistics. Okay? Proceed tayo by variate correlations. Sabi natin kanina, doon sa degree of relationship, kung meron akong isang variable at i-correlate ko sa isa pang variable, then by variate correlation. By variate na dalawang variable pinag-correlate. So the bivariate correlations procedure computes three coefficients. The first one is the Pearson correlation coefficient, which is the most common. Ngayon, kung mayroong problema, hindi siya continuous at ranking, pwedeng Spearman-Rho. At pwede rin Kendall-Taube. So correlations measures how variables or rank orders are related, but the relationship is not causal. Kasi nga, sa correlation, hindi ka naman nag-experimentation. Alam mo lang na may relationship na nag-exist, but you are not very sure that one causes the other because the relationship is not causal. Sabi ko nga, I can measure the length of your hair and correlate it with IQ at pwedeng positive or negative yung result, but the relationship is not causal. Your IQ is not being caused by your high or low or short or long hair. But the relationship might exist based on computed values. But theoretically, it doesn't make sense. Kaya nga ang correlation is not always causal. There is only an assumed pattern of linear relationship, but the relationship is never causal. So ano yung mga bivariate correlation? The first one is Pearson R. So example, students were given a test in math and were also given a test in science. So parehas na continuous, math and science. The researcher wants to find out if the students who got high scores in math also scored high in science. So a simple Pearson correlation R with confidence level of 95% will tell you the answer. So parehas na numbers, parehas na scale, parehas na continuous, Pearson R. Okay? Halimbawa naman, a researcher wants to find out if students' math performance, which is continuous, is related with level of anxiety, which is ordinal. Low, moderate, high, extremely high. So hindi na siya scores. hindi na siya continuous, ordinal na siya, hindi na siya interval, then spearman ang gagamitin natin. Rank. Nakarank kasi ito low, moderate, high, extremely high. Iko-correlate mo sa math performance. So it becomes Spearman rank correlation. Okay? How to do that? Yung Spearman, yung Pearson, later aralin natin yun sa statistics. The third example, students were given a test in math and their scores were ranked from highest to lowest. They were also given a test in science and the scores were ranked as well. The researcher wants to find out if the students who ranked high on the math test also ranked high on the science test. So kanina sa Pearson R, yung mismong score ang kinorelate. There are instances na hindi mo alam yung score. Ang binigay sa'yo ranking lang. From highest to lowest, nakarank siya sa first column. And then sa second column ay yung rank naman nila sa isa pang test. Whether that's a different subject or pre-test or post-test ranks. So if you want to find out the correlation between the two rank scores, then it's called Kendall-Tau B. Hindi siya Pearson kasi ang Pearson dapat ay parehas na score. Ang Kendall parehas na rank. Ang Spearman, ordinal yung isa. Okay? Do you see the difference between the three bivariate correlation? Ma'am Salviejo, do you understand that? Yung pagkakaiba ng tatlo? Parehong score, Pearson. Parehong rank score, Kendall. Yung isa ay score, yung isa naman ay ordinal, that is Spearman. Okay, so I hope that's clear. Partial correlations naman, nagko-correlate ka din dito, kaya lang meron kang control variable. The partial correlation procedure computes partial correlation coefficient describing the linear relationship between two variables while controlling for the effect of one or more additional variables. Let's have an example. Is there a significant relationship between length of time reviewing and test score? So gusto mo daw malaman, pag matagal bang nag-review, mataas ang test score, parehas na continuous, Pearson. Although you might expect any such relationship to be a positive, syempre naman, di ba, the longer the time of reviewing, ano expect mo, mas mataas ang score. You find out a study na merong significant negative correlation. Nakabasa ka daw ng study na may mga estudyante na ang haba-haba ng time na mag-review, pero nag-decrease ang kanilang grades. Sabi mo, baka may kinalaman yung time of the day. Baka mayroong effect yung haba ng pag-review mo doon sa grades mo kung sa umaga o sa gabi ka nagre-review. So the time of the day is observed and you want to control that. So ang tawag doon ay partial correlation. Para mawala yung agam-agam mo na walang kinalaman yung time of the day of reviewing na there is a positive relationship regardless of the time of the day because in your analysis, you were able to control that statistically. It's called partial correlations. Okay? Now, going beyond correlation is regression. So sa regression ay hindi mo lang basta ini-establish na may correlation sa kanilang dalawa, pero pwede ka nang makabuo ng linear equation such that you can predict the value of the dependent variable based on the value of the independent variable. So dito meron na tayong mathematical equation na equation of a line. So the math majors are very familiar with this. No? The y is equal to mx plus b. The y is the value of the dependent variable. Okay. M is the slope of the line. X is the value of the independent factor or the independent variable. B is the constant or the y-intercept. Now, the value of y when x is 0 is b. So that sounds mathematical. So wag nating i-confuse no, yung mga non-math major. Baka biglang mag-leave ng meeting. Pero ang ibig sabihin ng linear regression is that dahil makakagawa ka ng linear equation, pwede mo na daw hulaan Kung significant ang linear equation na ito, ay pwede mong hulaan kung ano yung magiging value ng y kung alam mo na yung value ng x. Ganun lang yun kasimple. At of course, may percent confidence level. Hindi naman 100% that your value is true. So you are 95% sure that the value of y is this based on the value of x is this because I know the constant m and I know the y coefficient. Okay? Pero hindi natin i-compute yung equation of a line, slope of the line na mano-mano sa statistics. The software will produce that for us. Ang gagawin mo lang ay kokopyahin lang doon sa table nasaan dyan yung m, saan yung slope, at nasaan ang constant. Sa equation na y is equal to mx plus b. So kung meron ka lang isang independent variable, it's called simple regression. Pag dalawa o higit pa ang iyong independent variable, it's called multiple regression. Pero iisa lang ang dependent variable. Pag marami kang dependent, marami kang independent, yun na yung tinatawag nating structural equation modeling or factor analysis. Pero pag isa lang ang DV, it's a simple or either simple or multiple regression. Let's have an example. Does grade point average predict performance in the licensure exam for teachers? Pag mataas daw ba ang GPA mo nung college, mapipredict ba natin at a certain confidence level kung ano yung magiging grade mo sa LET? So is the equation significant such that y is equal to mx plus b is a reliable equation to predict the value of y. In this case, your y is licensure exam, your x is grade point average. So ano kaya yung value ng constant? If everything else is 0, what is y? Yun ibig sabihin nun. Pag wala pang effect ang anumang variable, y is equal to b. Doon sa equation na y is equal to mx plus b, if everything else do not affect the y, pag siniro ko yung x, the whole y becomes the value of b. Tama ba yun, Ivan? Ivan?
Hello po, sir. Sorry po.
Doon sa equation na y is equal to mx plus b, when everything else is 0, the value of y is b. Tama?
Yes po, sir.
So, kung alam mo yung b at alam mo yung m, di ba, madidetermine mo na yung value ng y.
Yes, sir.
So, yung slope daw ba niya is significant? Ganon. So, yung steep ba no, ng rise over run o yung slope of the line is significant such that we can use that to predict values. Okay? So, ang gagawin natin sa simple linear regression ay i-determine natin yung equation of the line without using, of course, scatter plots. No, hindi natin mano-mano na i-scatter plot yung value ng x and y pairs, kundi automatic the SPSS or the Jamovi will do that for us. Pero tayo ang mag-a-analyze. No? So wala lang dahilan ngayon actually kung ba't hindi mo maintindihan ng stat kasi hindi ka naman nagko-compute. Wala namang ginagawang computation na sa SPS. Okay? So ulitin ko, simple linear regression, isa lang yung ID predicting a variable. Now, if I have sets, or if I have a set rather of independent variable, example, do gender, type of school graduated from, average grades in Gen Ed, Prof Ed, and Major predict performance in the essential exam for teachers. So hindi lang GPA, kundi meron pang gender. Pwede ba silang gender? Hindi naman siya continuous. Sabi natin kanina sa unang slides, pwede ang categorical basta dichotomize. So gender is dichotomized. Type of school graduated from can also be dichotomized. So they can be used as predictors in the multiple regression equation. So this time, hindi na y is equal to mx plus b lang ang equation mo. Magiging y is equal to mx sub 1. O, di ba? Meron ng mx sub 1 plus mx sub 2 Plus lagi. Pero meron tayong negative predictor at meron tayong positive predictor. May insert mo din yung later sa equation kung positive or negative siya. Basta ang dulo niya is plus b. The b is the constant pa rin. So, instead na x lang, doon sa, ulitin ko, instead na equation mo lang ay y is equal to mx plus b, yung x na yon ay magkakaroon ka na ng series of x. X sub 1, that's gender, plus the x sub 2 is the school, x sub 3 is the average grade in Gen Ed, x sub 4, x sub 5, plus b, the constant or the y-intercept. Can we predict licensure exam for teachers? At hindi lang yon ang masasagot mo sa multiple regression, which best predict it. So alin ang pinakamataas ang predictive value dito sa 5 variable na to? Is it gender? Is it type of school? Is it average grades in Gen Ed, Prop Ed, o major course lang ang magpipredict ng LET performance mo? So we can check that using multiple regression. Okay? Then meron din tayo tinatawag na hierarchical linear regression. Example ko muna. Do gender, type of school graduated from, average grade in general education, Prof. Ed. Ito rin yung example ko sa multiple linear regression. Dinugtungan ko lang. Controlling for the effect of attendance to review classes. May literature kang nabasa, halimbawa, na may mga estudyante na kahit na mababa ang grades sa Gen Ed, Prop Ed major, pero pag nag-review, pumapasa. Eh hindi ka naman interesado doon sa variable na yon, but you want to control the effect. So, isasama mo siya as a covariate or sa control variable. Ang tawag natin sa equation ay hierarchical linear regression. Ito yung katumbas niya sa ANOVA, factorial ANOVA. Ang katumbas nito sa correlation ay partial correlation. So whenever there is a control variable, you make it constant. Kasi pag hindi mo kinontrol yung effect of attendance, it might affect the prediction of LET performance because LET review is not only influenced by your independent variable, but it also be influenced by your attendance review class. Pwede mo rin kontrolin yung venue. Baka yung nag-exam sa Baguio, mas magaling kasi mas malamig. Ano pa? Pwede mo rin control yung number of times the test is taken. Okay? So those variables, whenever you want to control them, ang gagamitin mong equation ay hierarchical linear regression. Okay? So yung mga una ko nabanggit, lahat yun ay parametric tests with the assumption that that dependent variable or the outcome variable ay continuous, normally distributed, at saka observed from quantitative measures. Ngayon, may mga pagkakataon na yung ating mga variables o dependent variable natin ay hindi continuous, kundi nominal, groupings, o kaya hindi normally distributed. Doon papatak yung tinatawag nating non-parametric tests. Parametric, pagka continuous, yung mga DV, walang problema yung outcome variables natin. Kasi sa Pearson correlation, dapat continuous, normally distributed. Sa mean comparison, whether that is ANOVA, MANOVA, dapat ang DV mo ay continuous, normally distributed. Sa regression, dapat ang DV mo ay continuous din, na normally distributed. So in cases that it's not, then you resort to non-parametric test. We have phi coefficient, the chi-square test, the Mann-Whitney U test, meron din tayong Friedman test, the Kramer's B, and Wilcoxon rank test. So lahat ng itong mga non-parametric test na ito, aaralin natin ito isa-isa sa stats class. Although ito ay hindi na masyadong ginagamit ngayon dahil these are weak analysis and most likely it does not conform with standards of publication. So kung ito yung mga test na ginamit mo, kumbaga tataas ang kilay noong publisher o noong editor kasi these are weak analysis primarily because they are based from non-parametric tests. Walang quantitative measures, no, qualitative yung groupings mo. I'll give an example. You want to determine the association between gender, male and female, and opinion on same-sex marriage. Pero yung opinion mo, it's not measured on a scale, but it's just measured using a dichotomous, are you in favor or not in favor? So parehas na silang nominal. Gender is nominal, male and female. Tapos yung DB mo, nominal din. Favor, not in favor. While it's true that you can test for the difference between gender opinion on same-sex marriage, it is not as robust or not as strong as an analysis wherein your opinion is measured on a scale. You have several items in which they are answering, pero it talks about opinion and then merong summary ng grades or scores, then magiging interval siya. So opinion pa din yung DV mo, pero hindi na siya yes or no or favor, not in favor. So mas malakas yung analysis na yon kaysa dun sa non-parametric test. Pero lahat ng itong ating mga, so in particular, for this problem, the test that we are going to use here is the phi coefficient. Ang phi coefficient ay ginagamit if you have two groups at dalawa lang din yung responses. Male and female, dalawa. Favor, not in favor, dalawa din. So it's a phi coefficient. Yung chi-square naman, pwedeng dalawang grouping, tatlo yung sa kabila. Pwedeng tatlo sa IV, pwedeng tatlo din. So it can accommodate more than two. That's chi-square. Yung Mann-Whitney naman, dalawa yung IV, tapos yung sagot nila ay ranking. Okay? Yung Friedman test naman, tatlo yung groupings, pero rank yung sagot. Okay? So all the details of those non-parametric tests will be studied very shortly or very quickly in our statistics class. Pero I doubt kung merong mag-proposal this point in time na ang test na gagamitin ay non-parametric test. If ever, yun. If ever na ganun yung test mo, then later na lang tayo mag-discussion kung ano ang appropriate nito. But I am telling you now at this point in time, I think the panel will not agree for a proposal at this point in time for a graduate program na non-parametric test yung gagamitin, considering that variables can be expressed now numerically, quantitatively using scales. With the availability of measures in the internet and the generosity of researchers to share their measures or the instruments to gather data based on your variable, I think there's no reason for you na hindi mag-parametric test gagamitin natin. Ito yung gagamitin mo kung talagang wala ka nang magawa. Like for example, nag-parametric ka to begin with, kaya lang skewed yung data. It's not normally distributed. So remediation na lang ito. Ang remedyo ko na lang para matuloy yung analysis is gawin ko siyang non-parametric test. I-rank ko na lang po yung scores. Igugrupo ko na lang po yung scores. Because the data shows that it's not normally distributed nor it conforms with the parametric standards. Okay? So, do you have any questions so far? So, we'll spend the next 30 minutes or so bago maubos yung data ni teacher sa katabi. Do you have any specific questions in mind? Actually, this is our last lesson. The next weeks will be devoted for you to write the proposal and then mag-schedule lang tayo ng isang Saturday for the final exam. So, that's it. Any questions? So, I'll stop sharing now for a while. Dapat may question kayo bawat isa kayo. In terms of the statistical tool that you're going to use. Okay, magtatanong ako ngayon si Sir Jose Leonardo. Sir Jose, can you recall or can you share with us kung ano yung research hypothesis na balak mo dun sa proposal na isasubmit mo o gagawin mo?
Hindi pa po ako nakakapili pero wait lang po, tignan ko.
Kasi yun yung last activity na gagawin ninyo for this lesson. Based on your research question and hypothesis, anong statistical tool ang gagamitin nyo and explain why. Ganun lang kasimple. So lahat kayo ganun. Yung last assignment niyo activity is i-identify nyo yung stat based on the lesson that we have discussed so far. Unless the lesson is highly qualitative. So for those who will do a highly qualitative research design, you do the same task, but it's your own searching now of materials that will guide you in terms of statistical analysis. Although iisa na ang laman, umiikot. Pag sinabing qualitative, halos thematic analysis lang naman ang kanilang nagiging procedure for analysis. Yes, sir. To begin with, ano yung working problem mo o working hypothesis that you have submitted so far?
Yung research po ba na yung pinasa ko po ng mga ay mga
Yung ginawan mo ng research question at hypothesis. O si Von nga, paringan natin si Von habang organize ni Sir Leonardo. Sir Von, ano yung problem mo doon sa yung tentative problem?
Sir, yung general statement po ng research problem ko po is, to determine if having classical music as background music during the teaching and learning process of high school students affects their mathematical performance.
Okay, so ano yung hypothesis mo?
Yung null hypothesis ko po, sir, the classical music as background music while studying has no effect to the high school students' mathematical performance.
So, ano yung approach na nakikita mo paano mo to gagawin? Paki-explain nga very quickly, how are you going to do this?
Para kung medyo experimental po siya.
Sige, tuloy lang.
Bali po ang magiging process po is, bago po magturo, mag-pre-test po muna sa mga students para po malaman yung parang prior knowledge po nila. Then, mag-experiment na po, mag-teaching na po with background music po habang nagtuturo. And then, after po magturo ng may background music na po, mag-pre-test na po yung student. Ay, magpo-post test po yung students para po malaman kung nakatulong po ba or naka-increase po sa mathematical performance po ng students.
And then? So, may grouping of students ka ba dito sa experiment mo?
Ano ko po, sir, isang section po. Section po yung EX.
So, one group lang, ganon. O, mahirap i-roll out yun yung effects ng ibang variable pag isang group lang.
So, pwede naman din po dagdagan, sir. Siguro po, na lang po. Yung isang group po, makakatanggap po sila nung may background music na teaching. Then,
So may presence of control, di ba? So kung dalawang groupings yon na randomly assigned siya at i-compare mo later yung post-test nila sa test, anong statistics ang gagamitin? Base doon sa presentation natin. Sir Von. I-compare mo yung math performance ng dalawang grupo, yung isa control, yung isa yung experiment. Anong test ang gagamitin? Salamat po. Tol, may nakita yata ako nag-raise ng hand kanina. Who is that? May tanong ba? Yung cursor ko yata yun. Obis kamay. Anyone who would like to ask? Yes, Miss Dupitas.
Sir, itatanong ko lang po sir kung ano pong statistical tool or technique ang gagamitin pag mediation po tsaka moderation. Is it ano rin po ba?
Regression yun.
Correlation din po ba? Regression.
Moderation and mediation analysis are combinations of regression and factorial analysis in one. Pero most likely, the elements of regression ay nandun. Pero sa moderation, ay sa mediation kasi ngayon, hindi na regression lagay nila. No? Structural equation modeling will be used. Ganun na yun. Combination kasi siya. Pero actually, in essence, you do a regression analysis for each path of the equation doon sa moderation analysis. Yung standard na moderation ha, if you have one IB, you have one DB, and one is moderator, that is series of regression. IB to DB, that's one. Moderator to the DB, that's another. Ganun. Then IB to the moderator. So, puro regression analysis yan. Yung regression, to test the regression. Specifically, hierarchical regression analysis. So, ang gagawin natin ganito. Para magkaroon kayo ng klaro pang idea kung ano yung, how do we write the statistical tool for each of the problem. The articles that are already published in journals can be used as good references. Kasi nakalagay doon, doon sa sinearch mo halimbawa ng moderation analysis, then magmo-moderation analysis ka din, tignan mo kung paano sinulat doon sa data analysis part ng journal yung regression analysis na sinasabi natin. Those can be good source of reference in as far as how you write. Kasi hindi naman pwedeng ilagay mo lang doon sa proposal ay statistical analysis, ano ba? Hindi ganoon. Kailangan naka-expound yung statistics. Hindi naman pwedeng statistical analysis, t-test. So it has to be explained also. Why? Why t-test? And why not the other test? Okay. So on Saturday, hindi na tayo mag-meet, pero gagawin nyo lang yung statistical, yun lang isasubmit nyo, yung the appropriateness of the statistical tool. And then I want you to devote the time that we have para wala kayong excuse na hindi nyo nagawa is our meeting next Saturday shall be devoted for your writing. So gamitin nyo na yung format ng ating research format na binigay ko sa inyo to draft the proposal that you plan. So pagsasama-samahin nyo na yung mga elements na sinubmit natin, although they are not arranged in that order, you are going to put them where necessary, add the necessary part. Yun namang gawa yung mga locale of the study at yung ibang parts nun na meron at hindi natin nagawang activity, then please try to incorporate them. And then magsiset na tayo for deadline, and then magsiset tayo ng day for our final exam. Actually, we still have the whole month, no, to do it kasi ang final exam ay December pa naman. Pero wag nating, ano ang gusto nyo? Mauna ang bago yung final submission of paper, or final paper is submitted first before the exam? O sabay na lang?
Sabay na lang po, sir.
Sir Riniel? Sabay na lang?
Opo, sir. Para sa akin po.
So, siguro, ang gagawin natin is that hindi siguro sabay na sabay, kundi halimbawa lang, halimbawa mag-set tayo ng exam ng Saturday. Halimbawa lang, can you give me a Saturday on December? Halimbawa lang December 9. Hypothetical, di ko alam halimbawa December 9 ang sinet natin na Saturday. So ang gagawin ko, magde-deadline ako ng paper ng December 8. Para yung exam natin, hindi ko i-assign to all. So sa Google Quiz natin, kung ilalagay yung exam, mag-exam tayo ng 2 to 5. Konti lang naman yung exam na yon. Pero i-assign ko lang yung question. Nakabantay lang ako such that I will only assign yung mapapadala at sino lang ang magpapadala sa akin ng response in the final exam. Is that a fair compromise? Halimbawa lang, it's a December 9 exam, then it's December 8, something like that. Para pagkatapos ng exam, tapos na rin yung requirement. Hindi yung, ay, magpapa-incomplete na lang ako. Bawal ma-incomplete. Bawal ang dapat may grade lahat sa dulo. Okay? So, i-arrange na lang natin later yung date, pero I will arrange it as early as possible para walang maging conflict. Kumbaga mauuna tayong mag-set ng ating exam para maunahan natin yung ibang subjects nyo. But you have a lot of time remaining for you to write the proposal. Wala na tayong defense, no? Because ganun din naman yun eh. Kung kaya mong isulat, kaya mo rin i-explain. So I believe in that principle, no? Na parang repetition na lang yun eh. Darating din tayo sa part na i-defend mo siya, yung pulido na, pero ako, ang minimum requirement ko lang dito sa klase natin is ma-submit mo yung maayos na proposal, tignan natin yung the way you conceptualize it is theoretically sound, then tama yung mga parts niya. So hindi na natin kailangan ng i-defend mo pa yung proposal na yun. Okay? So a simple write-up will suffice, no, in as far as the requirement is concerned. Unless tayo ay face-to-face. Kasi kung tayo ay ganito lang din, mag-go online din lang tayo ng defense. I think that's very cumbersome, no, on our end. Kasi basta hindi rin siya ma-maximize. So okay na ako doon sa requirement na makapag-submit ka lang ng more or less a sound no proposal for your proposal. Ngayon, pwedeng magbago ano, yung mga activities na yon, pwede namang magbago all throughout, no? Complete 360, iba na yung gagawin mo, iba na yung problem, iba na yung hypothesis. It doesn't matter as long as you can submit that on the specified date. Pero sayang kasi yung effort, di ba? Sayang yung effort nung ginawa mo ng literature review, yung conceptualization, yung framework, yung question, yung instruments, kung paiba-iba yung gagawin nating topic o mag-iiba ka pa at this point in time. But you still have a month or so to prepare that. So we have several weeks from now before the submission. So I think you have a lot of time working on that paper. Then, while you are working on that paper, you are still welcome to ask clarificatory questions in our GC. In case you would like to ask questions pertaining to the preparations that you are doing, so that hindi naman you are given now the full liberty, tapos at the end of the day, ala pa lang ma-submit na maayos kasi ayaw namang magtanong. Okay? So please maximize our opportunity to ask. Yes, Riniel.
Sir, nagde-decline po kayo ng proposal po, sir?
In my end, it's not yet my part. No, hindi ko pa task yun na magde-decline ako ng proposal because this is a methods of research class. Pagka nag-work na kayo with your advisor at meron na kayong target na kailangan makapag-publish ka kasi requirement na natin yun before you graduate, makakatulong lang yung requirement na gagawin nyo dito na meron na kayong working title, meron kayong working proposal. So after that, pag na-satisfy nyo na yung requirement na yun at nabigyan ko ng grade, hanggang doon lang yung gagawin ko. So it's not I'm not in the authority to say, this proposal goes to the trash bin and this one goes out of the window and the other one goes to the kalan, pang sungrod, gano'n. I'm not tasked to do that. I-evaluatein ko, kung mababa ang grade, mababa na ang grade. Pag mataas ang grade, mataas na ang grade. Pero kung ito ay reject o hindi reject, si mentor na yon, yung assigned advisor na yon.
Okay po, sir. Thank you po.
Okay. Any other question? Kaya ako naman, ang advice ko, pagbutihin nyo na doon sa methods of research class pa lang. Dito sa subject na ito, kung ayusin mo na yung proposal, hindi naman yon masasayang. Kung nag-exert ka ng effort, hindi siya masasayang. Actually, you are hitting two birds in a stone. Kino-comply mo na yung grade requirement na mataas dito sa ating subject. At the same time, you are preparing for the opportunity na mataas yung approval rating ng iyong magiging submission sa iyong advisor o sa iyong mentor. Kaya sa yung, sige, wardi-wardi muna. Sabi ni sir, hindi naman pala niya i-reject. O di wardi-wardi muna, burot-burot mo ng proposal. And then, saka kayo mag-i-effort ulit. So, sayang naman. So, pagbutihin mo na doon sa unang part pa lang para tuloy-tuloy na yon. Kasi, lalo sa inyo, yung MSGC at saka itong math, minsan, madalas, kung hindi ako ang advisor niyo, kasama rin ako sa member. For the MSGC, I cannot serve as an advisor kasi hindi ako MSGC, MS, or PhD. Pero I sit as member of the panel. So alam ko din. So ngayon, halimbawa, burot-burot lang yung pinas mo, o di may marka kasi hindi ko naman mare-reject, mababa lang yung grade. Pero pagkakasama ko sa panel mo, at yun pa rin burot-burot na yun, yung sinabit mo later, doon ako merong karapatan na may authority na ako na ayokong pumayag na gano'n yung research. Ganun. Doon na ako magkakaroon ng authority to do so. Gano'n din sa mga MS Ed Math, merong ma-assign sa aking ilan, siguro pinakamarami na yung 2, and at the same time, I serve also as member of the panel. So similarly, I can say whether you can push through or not pag nandun tayo sa defense ng proposal kasi yun na yung formal na thesis mo. Ito kasi pwede pang magbago eh. But I'm telling you, to maximize the time, huwag na. Huwag nang pabago-bago. Pagbutihin na doon sa unang time pa lang na pinag-submit ko kayo ng proposal. Kasi sa susunod na mga semesters ninyo, may mga topics kayo o may mga subjects kayo na i-require ulit na related sa proposal na ginawa. So you work on the same problem from time to time hanggang sa makarating ka doon sa proposal defense mo sa dulo, pulidong-pulido na siya kasi ilang beses mo na siyang naisang. But of course, along the way, you will discover inconsistencies of comments, di ba? Ayaw ni teacher nito, gusto nitong teacher na ganito. So, yeah, iba-iba yun rin yung appreciation ng faculty doon sa papel. You have to be ready for that. There will come a time that you will drop names pa nga eh. Sasabi ni Clermine, sabi ni Sir Elmer, pwede na daw to. Yeah. Siyempre, hindi ko naman maririnig, di ba? O sasabi ni Ross Ivan, magkaiba naman si Sir Elmer at si Sir Edwin ang sinasabi. Mano mag-usap na lang sila. Ganun. You will be encountering such scenarios. Although, that's the reality na syempre meron tayong kanya-kanyang appreciation of output of students. But at the end of the day, lalo na sa proposal events, we will encounter inconsistencies, but the target there is to resolve these differences in terms of the way we appreciate the proposal. At ang ending, happy ending pa din. Like, okay, go. Pero ito ang gagawin. Okay? Are we good?
Yes po, sir.
Yes,
Yung
sir.
iba? Okay ba yung iba? Anyway, balik-balikan nyo na lang yung recordings natin. Pero I would encourage you to ask questions in our GC so that we can expound further kung mayroong katanungan. Okay, so I hope to see you around next semester because I think we are being compelled now to have classes face-to-face. I am excited to see you in our statistics class. No? I am dying to see ng SU. Diba? Yung tipong alam ko maraming limitations yung module, hindi mo kayang ibigay lahat, no? Yung gusto mong ibigay because of the limitations of this setup. So I hope next semester we will all be seeing each other and stay healthy. Okay?
Yes, sir.
Sa stat class na natin pag-blow outin yung mga DOST because I cannot I will not accept virtual snacks. Hindi na so